Quadratic equations in one variable can be solved by four methods. We have extracting square roots, factoring, completing the square, and quadratic formula. Fractional exponents correlate with radicals. I'm going to explain that fractional exponents resembles radicals. So this is the exponential form of the expression x raised to 2/3. X raised to 2/3, this is the exponential form, wherein x is the base, 2/3 is the exponent, 3 is the denominator of the exponent, and 2 is the numerator of the exponent. Then the exponential form or the exponential expression is x raised to 2/3. This exponential form or the exponential expression can be changed to radical form. The radical form of x raised to 2/3 is this one, the cube root of x squared, or the quantity squared of the cube root of x. I repeat, this is the quantity squared of the cube root of x. These two here are the same. In the radical form, x here is the radicand. In the exponential form, x is the base. Then, 3 is the index of the root or the index of the radical. In the exponential form, 3 is the denominator of the exponent. Since in the exponential form, once it is a fractional exponent, that resembles radicals. So this is the radical sign for a fractional exponent. So this one, the cube root of x squared, is known as the radical expression or the radical form. So with the quantity squared, the quantity squared of the cube root of x. I repeat, the quantity squared of the cube root of x. These two here are the same. And these two here are the radical form of the exponential form x raised to 2/3. Another, x raised to 1/2. The exponent is 1/2. X here is the base, 2 is the denominator of the exponent, 1 is the numerator of the exponent, and 1/2 is the exponent of the exponential expression. So changing the exponential form of x raised to 1/2 to radical form. This is the square root of x raised to 1, or the quantity raised to 1 of square root of x, or simply the square root of x. In here, x is the radicand and x is the base of the exponent. Then 2 is the index of the root, and the index of the root is written in the pouch. It's here. Since the index of the root is 2, it is not needed to write 2 because it is understood that it has the index of the root, which is 2 in here. Then the numerator of the exponent, which is 1, it's here. It is understood that it has the exponent of 1 here and this one. So it is not needed to write 1 as the exponent. So this is the radical form of the exponential expression x raised to 1/2. This is the same as the square root of x. And this is the radical form. Once the numerator of the exponent is 1, you don't need to write 1 as the exponent here. So you can write like this, and once the denominator of the exponent in a fractional form, you don't need to write 2 in the pouch as this one. So this is the square root of x. So let's proceed now to extracting square roots. So the instruction here, solving quadratic equations in one variable by extracting square roots. So in here, in extracting square roots, you have, or in solving quadratic equations in one variable, all you need to do is make the unknown or the variable be alone at the left side of the equation or at the other side of the equation. Let the unknown be alone, whether it is at the left side or whether it is at the right side, as long as the unknown is alone. So since the unknown here is at the left side, so let's have this one. We don't need to rearrange the terms rather. So this is x squared. Since we are solving for x, the exponent should be eliminated as well as the numerical coefficient. Since the numerical coefficient of x squared is 1, so we don't need to eliminate it anymore. We want to eliminate the exponent 2 of x. So equals, in order to eliminate the exponent of the base, we have to multiply the exponents we have to multiply the exponent by its reciprocal, and the reciprocal of 2 is 1/2. Then you copy 49. What is added to the left side of the equation should be added also to the right side of the equation. Thus, we added exponent 1/2 to the left side. So, we are going to write exponent 1/2 to the right side of the equation. Thus, making now x 2 times 1/2 becomes 2/2 is equal to 49 raised to 1/2. Then x 2 divided by 2 is 1. We don't need to write 1 as the exponent of x. And since this is fractional exponent and this is 1/2, then this resembles the square root. Okay. And we have the base, which is 49. But take note that once it is a quadratic equation, it has two roots. One is positive and the other is negative. So x now is equal to positive and negative. The square root of 49 is 7. Because the explanation here is, why is it positive 7? Because 7 times 7, positive 7 times positive 7 is positive 49. The other one is negative 7 times negative 7 is equal to positive 49. So in other words, it is a quadratic. Once it is a quadratic equation, it has two roots. It has two solutions. One is positive 7, the other is negative 7. Okay. Or another solution. This is the shortcut method. X squared equals 49. So, as I told you a while ago, that the unknown should be alone at one side of the equation. No exponents greater than 1 and no numerical coefficients greater than 1. So, since the exponent of the variable x is 2, we will eliminate 2. So, this is the shortcut method. In eliminating 2, in transferring this to the other side of the equation, this becomes, so in transferring this, you write its reciprocal. So 2, when it is, the exponent 2, when it is transferred to the right side of the equation, becomes its reciprocal, and this is 1/2. So x now equals, since this is a fractional exponent, and the fractional exponent of 1/2 resembles square root. So the base is 49, which is the radicand, and you have this positive and negative. So positive and negative square root of 49, x is equal to positive and negative 7. These values of x are the same as this one. This is the long method, and this is the shortcut method. So you can also write x is equal to 7 and x is equal to negative 7. You can have this one as your final answer, or you can have this one as your final answer. In here, you can also write x is equal to positive 7, or without using positive, x is equal to negative 7. Okay, without writing the positive sign here, this is okay. Next is y squared minus 225 equals 0. Since the two terms here are located at the left side of the equation, so transferring this to the other side of the equation, we will use the transferring of one term to another term. So this becomes y squared equals, since negative 225 crosses the equal sign, then this becomes positive 225. What is left here at the left side of the equation is y squared. So eliminating the exponent 2 using the long method, y squared, then multiply it by its reciprocal, which is 1/2, equals 225. What is added to the left side of the equation should be added also to the right side of the equation. We added 1/2. Then we write 1/2. 1. So y, 2 times 1/2, 2 times 1 is 2 over 2 equals 225 raised to 1/2. Then this is cancelled out. So y, 2 divided by 2 is 1. And then, since this is a fractional exponent of 1/2, then that resembles the square root. 225 positive or negative. So y now is equal to positive or negative square root of 225 is 15. You can write y is equal to 15 and y is equal to negative 15. Or the shortcut method is, or y squared minus 225 equals 0. So y squared is equal to, transferring this to the other side, is 225. Then y, eliminating the exponent, transferring this to the other side of the equation, 225 raised to 1/2. Then y is equal to positive or negative square root of 225. So y is equal to positive or negative 15. So this is y is equal to positive 15 and y is equal to negative 15. You can have this one as your final answer, or you can have this as your final answer. So with this one, and this one. The next equation is 4y squared equals 64. In here, this equation has a numerical coefficient of 4 and the exponent of 2. So we will eliminate the exponent 2 and the numerical coefficient 4. So eliminating first the numerical coefficient. So we have 4y squared over, since we want to eliminate the numerical coefficient of 4, then we have to divide it by 4 equals 64. What is added to the left side of the equation? It should be added also to the right side of the equation. We added over 4, so right over 4. This is cancelled out. So y, what is left here is y squared equals 64 divided by 4 is 16. Then, eliminating also exponent 2. Thus making now y raised to 2, in order to eliminate the exponent, multiply it by its reciprocal, and the reciprocal of 2 is 1/2, equals 16. Then, 1/2 is added to the left side of the equation. Then, we also add 1/2 to the right side of the equation. Thus, making now the equation, 2 times 1 is 2 over 2. This is the exponent, equals 16 raised to 1/2. And this 2 divided by 2 is 1. This is cancelled out. What is left here is y is equal to, since it has 16 here has a 1/2 exponent that resembles the square root. We have 16 positive or negative. So y now is equal to positive or negative square root of 16 is 4. Or you can have y is equal to positive 4 and y is equal to negative 4. You can have this values, or you can have these solutions or roots of the equation 4y squared equals 64, or you can have this as your final answer. For the shortcut method of 4y squared equals 64. So eliminating the numerical coefficient of the variable y, we have 4 or we can have y squared equals, since this is multiplication 4y squared, this is multiplication, so the opposite is division. So in transferring this to the other side, it becomes the denominator of the terms at the right side. We have 4. You can have, if there are many terms, all the terms here at the right side become, all the terms at the right side becomes the numerator. Since we have only 1, so we have 64 as our numerator. So y squared is equal to 64 divided by 4. This is 16. And we want to eliminate 2 of the exponent y. We have y is equal, transferring this to the other side, this is 16. Then write the reciprocal of 2, which is 1/2. And since 1/2 resembles square root, so the square root of 16, we have positive and negative. So y is equal to positive and negative 4. Or you can have y is equal to 4 and y is equal to negative 4. Okay, these two here are the same. So whether you do the shortcut method or the long method, then we have the same, we will have the same answers. We will get the same answers. The next here is this one. 5x squared minus 125. all the terms here are located at the left side of the equation. So transferring negative 125 to the right side, thus making now, we will use the transfer of terms from the left to right or from right to left. So we have here 5x squared equals, transferring this, we have 125. So negative 125 crosses the equal sign, then the sign changes from negative to positive. Then, using the property of equality, eliminating 5x squared over 5 equals 125 over 5. Thus, canceling 5, what is left here is x squared is equal to 125 divided by 5 is 25. Then, eliminating the exponent, 2, we have x squared times 1/2 equals 25 raised to 1/2. Then x, 2 times 1/2 is 2 squared equals 25 raised to 1/2. Then x now is equal to 25 raised to 1/2. This is the square root of 25, positive or negative. X is equal to positive or negative 5. You can have x is equal to 5 and x is equal to negative 5. So there are two roots for equation 5x squared minus 125 equals 0. Okay. Or another, we have 5x squared minus 125 equals 0. Then, doing the shortcut, we have eliminating 5. Transferring this first to the other side of the equation. 5x squared equals 125. Then eliminating 5. Since this is multiplication 5x squared, then the opposite of multiplication is division when it is transferred to the other side. X squared is equal to 5 becomes the denominator of the terms at the right side. Since this is only one term, so we have only 125 as our numerator. So x squared is equal to 125. Divide by 5 is 25. So x, eliminating the exponent, transferring this to the other side of the equation, it becomes its reciprocal. And the reciprocal of 2 is 1/2. This is a fractional exponent which resembles, since the exponent here is 1/2, resembles the square root. We have 25. So positive and negative. X is equal to positive and negative. The square root of 25 is 5. Then you can have x is equal to positive 5, x is equal to negative 5. These are now the roots of the given quadratic equation, 5x squared minus 125 equals 0. Or you can have this as your final answer. Okay, thank you.